In some countries, AC voltage has a frequency of 50 Hz, while in others it is 60 Hz. Have you ever wondered how this frequency is generated? In this video, you will explore this. First, let's understand what is a frequency. We define a frequency as a number of cycles per second and it is measured in the unit of Hertz. As in the first diagram we have 1 cycle and let's the time from here to here is 1 second. So 1 cycle is generated in 1 second, therefore the frequency in this case is 1 Hertz. In the second diagram we have 2 cycles. One cycle completes here and the second cycle completes here. And let's the time from here to here is 1 second. So we have 2 cycles in 1 second. So the frequency of this diagram is 2 Hz. Similarly, if 50 such cycles generated in 1 second, then the frequency will be 50 Hz. So 50 Hz means 50 cycles per second. And if 60 such cycles generated in 1 second, then the frequency will be 60 Hz. Now let's come to the main question, how frequency is generated. The AC voltage is produced by a synchronous generator. A synchronous generator is composed of a magnetic field placed on the rotor and armature winding placed on the stator. When this magnet rotates inside the stator, then it produces a EMF in the armature winding. So we get a three-phase AC voltage from here. The voltage of each phase is a sinusoidal like that. So it has a frequency. The frequency of this AC voltage can be found by using the formula F is equal to P into Ns divided by 120. Here F is the frequency of generated EMF, P is the number of magnet poles on the rotor, and Ns is the speed with which the rotor rotates inside the stator. In this example, we have 2 poles on the rotor, so we put 2 in place of P into Ns divided by 120. Now if you want the frequency to be 50 Hz, solving this for Ns, then we get the value of Ns is equal to 1500 rpm. It means if this rotor is rotated with 1500 rpm, then the frequency of the generated EMF will be 50 Hz. Similarly, if you want the frequency to be 60 Hz, if we solve this for Ns, then we get the value of Ns is equal to 3600 rpm. So if this rotor is rotated with 3600 rpm, then the frequency of the generated EMF will be 60 Hz. From this discussion, it is clear to increase the frequency, we should have to increase the speed of the rotor. Now let's take another example. In this example, we have 4-pole rotor. We want to calculate the frequency of the generated EMF in this case. In this case, the value of P is 4, so we put 4 in place of P. Now we want to calculate the value of Ns for 50 Hz and for 60 Hz. If we have required 50 Hz frequency here, solving for Ns we get the value of 1500 rpm. It means if the rotor is rotated with this speed, then the frequency of generated EMF will be 50 Hz. If we solve this equation for 60 Hz, solving for Ns we get 1800 rpm. So if this 4-pole rotor is rotated with 1800 rpm, then the frequency of the generated EMF will be 60 Hz. In next video lecture, we will discuss why power plants generate EMF in the frequency of 50 Hz or in the frequency of 60 Hz. Why not we use the other frequencies? If this video has helped you, then like the video and subscribe the channel for more interesting videos.